Okay, just a reminder that I split characteristics of linear functions into two videos. There's this A that's going to be over just the basics, and B, which will be over the second part is over actually writing the equations. There's a lot more involved there. So on here, this is just going through the basics. We've talked about y equals x quite a bit. We remember that that's that nice pretty diagonal. So go ahead and write that in for your linear parent, and go ahead and draw on your diagonal like we've done in class quite a few times. And remember that on your line, y equals x. Whatever your x value is, your y value is going to be the exact same thing. Okay, so you really can put any numbers over here on the left. You just have to make sure that those numbers are the exact same on the right. It's y equals x. Okay, even though this is x and this is y, they're still going to be equal. Okay. Remember, your domain is left to right forever on a line, so that'll make it all real numbers, and your range is the same thing, up and down forever, so that's all real numbers. As x increases, y increases, and x decreases, y decreases. Okay? These three guys right here are real important. These are your different forms of your equation. Y equals mx plus b, very familiar with slope-intercept form. We've been doing that a bunch. Remember that the slope, let me use a different color. Just remember that m is your slope. No, it didn't work. Try again, sorry. I guess you can keep copying. By the way, if you haven't gotten the top, because I know I'm talking fast, you need to pause it and copy the top. But, I give up. All right, m is your slope, and b is your y-intercept, always, okay? And your y-intercept will look like this sometimes as an ordered pair, okay? All right, point-slope form, should have used it a little bit in Algebra 1. It just simply means that when you're given the slope and a point, you're given 1 point, x1, y1, whatever it is, you can take those and plug them into that form. So be familiar with what that form looks like, and we'll do one of those. There's actually one of those done on the part B of this. And then of course standard form. What's real important that you know is that standard form can't have any fractions, so that's kind of nice. And A has to be positive, so make sure you make a note of that. No fractions. AX plus BY equals C, so it'd have to look like 5x plus 3y equals 14 or something like that. You can have negatives for your y and your constant, but you just can't have a negative out in here, out in front of that x. Okay? We come down this way. Slope-intercept form, a lot going on with slope-intercept form. I know that's a lot to write, but you need to know it. Of course, you can abbreviate, but you need to know that your slope, when your slope is 1, there's no change in the parent function. When slope is greater than 1, or excuse me, greater than 0, you're going to have a positive line from left to right. When the slope is negative, less than 0, it's going to go left to right, going down, decreasing. So this would look like this. This would look like this. Nope, that's wrong. Let me try again. Negative. This would be like this. Okay? And then if your number, just the number itself, not worrying about signage or anything, that's why there's absolute value signs around this, but just your number itself. Remember, the bigger your slope is, the steeper that graph's going to get. It's going to get steeper and steeper. You know, it'll get steeper, and it'll get steeper and steeper, the bigger that number gets, okay? And then remember, if it's a fraction, the smaller that fraction gets, the flatter it becomes. Okay, it gets less and less steep. That's why when you get down to 0, you have that horizontal line. Okay, all right. Your changes in B are right there. If it's greater than 0, it shifts up. If it's less than 0, it shifts down. Make sure you know all that. All right, let's go to the next page. All right. We did this part in class, but in case you were absent, you need to copy that real quick. You can copy that. There it is. Okay. If you need that, copy that. You just pause for each part of that. Okay? All right. Next page. Okay. Whoops. That didn't work out so great. Okay. Finding equations. If you have the slope and y-intercept, you're going to use slope-intercept form. That makes sense because you have the slope and the intercept. If you're given the slope and one of the points, then you're going to use point-slope. Remember, you have the slope that you'll be given, and then you'll also have a point that you're given, whatever it may be. Okay? Coordinates for 2 points. You're going to have to find the slope first, and then you can plug it into point-slope form, or you actually can even plug it into slope-intercept form, and we'll look at both of those. That's in your Part B. And a table of data, calculator's list, do a linear regression. I'm going to show you how to do that on Thursday. Okay? Horizontal lines, real important. Remember, those are always going to be y equals. They have a slope of 0, and they always look like this, and they're going to equal some number. So y equals 3 would look like this. 1, 2, 3. Okay? It would go through y equals 3 and it would be horizontal. Okay? A vertical line, remember, has undefined slope. Ooh, I cursed. And it's always going to be x equals a number. So let's say x equals -5 would look something like this. It would be left 5 because that's your x-axis. And then it would be vertical through there. Okay? So that would be the line x equals -5. Parallel lines, remember, they always have to have equal slopes. So if one of your lines is y equals 2x and the plus 1, then the other line could be y equals 2x minus 5. It really doesn't matter what the y-intercept is as long as these slopes are the same. Okay? And then for perpendicular lines, remember, those are going to be the opposite reciprocal. So here the original is 2 over 1. So the opposite reciprocal of that, you change the sign and reciprocate it, so you get -1/2. Okay? So those two slopes are perpendicular. If you had 3 halves, the opposite, the perpendicular, would be -2/3. Okay? So just a little review on that. All right. I think that will get us through. The rest of it we should be able to do.